Hello everyone, this is Stephen Green. This is the IT 6843 ethical hacking class, and this is my graduate project. We chose different topics, and my topic was Cupid attacks and Heartbleed. So let's begin. We'll do an introduction here. Heartbleed, I'm sure most of you have heard of Heartbleed or are aware of it and saw it on the news, so it's not going to come as a complete surprise to you guys as to what it might be. But Heartbleed, it's one of the most critical vulnerabilities to hit the World Wide Web in recent memory. There were millions of websites that were affected, and we'll get into that a little bit later as to why there were so many websites affected. But essentially, encryption was compromised, and this led to web, email, instant messaging, VPNs, all of these were vulnerable. And we're going to focus a little bit more on Cupid attacks. Cupid attacks is basically the sister of Heartbleed. It's the same thing, except it works over wireless networks. It violates wireless encryption. It allows the attacker to set up what are called evil networks, so you can steal data and exploit users. And you can steal private key data and certificate information from these. A little bit on the background. The main culprit here is OpenSSL. OpenSSL is an open source protocol. It's used for website and data encryption. Again, it's open source, so it's out there for anybody to use, and because of that, there's a lot of websites that do use it. SSL stands for Secure Socket Layer, and this is also known as TLS, or Transport Layer Security. So there you go, it's a security layer. It's been trusted since the 1990s. It does use public key encryption, and it's trusted by millions of websites for encryption services. Now, the bad side of OpenSSL is that there's millions of lines of code, as with any big software. So the more lines, the more bugs. And Camp, who was one of the resources I reviewed, suggested that this code is a mess, the documentation is misleading, and the defaults are deceptive. So basically, he trashes OpenSSL really bad. And for good reason, actually. So, limited support staff. OpenSSL is a project. It only has one full-time person on this project, and they have very limited resources. They have a very small operating budget to maintain and update the code with. And I know it's open source, and they have open source contributors, but you need to have someone full-time looking over this code, making the updates, applying the updates, etc. Now, what are heartbeats? Because heartbeats are what's behind Heartbleed. Heartbeats, they recur within the TLS layer. It's a packet that's sent to allow a peer to know that a user is still connected and that everything is okay with the TLS layer. So if you think about it, it is like a heartbeat. It lets you know that basically that user is still alive. It's supposed to answer with an exact copy of its original payload. That does not occur with Heartbleed. It serves to lower client and server overhead, and OpenSSL uses Heartbeat for these purposes. Now, the Heartbeat bug, as described by Louise Grangia, the Heartbeat bug allows anyone on the internet to read the memory of the systems protected by the vulnerable versions of OpenSSL software. This compromises the secret keys used to identify the service providers, to encrypt the traffic, the names and passwords of the users, and the actual content. This allows attackers to eavesdrop communications, steal data directly from the services and users, and to impersonate services and users. So you can see it's a pretty significant bug. Instead of responding to the Heartbeat request with a copy of the payload, it is instead returning a block of memory, and that's what is the issue with Heartbleed. So it doesn't return with a copy, it returns with memory, which is bad. This block of memory may contain data that includes usernames, passwords, certificate information, security keys, public key info, etc., etc. So basically all the stuff that you don't want discovered is right there and sent right back. This affects sites, software, and hardware. It includes routers, firewalls, printers, security cameras, Wi-Fi portals, etc. I mean, the list goes on. So building on the Heartbleed bug, we're going into Cupid attacks. So Cupid attacks are based on the same principle as Heartbleed, except attacks are perpetrated via the wireless networks. Wireless access points use EAP, which is Extensible Authentication Protocol, to authenticate users in the TLS layer, and this is what Cupid attacks exploit. So they exploit this to get the memory leaks, just like Heartbleed. Now, with Cupid attacks, the attacker can set up these evil wireless networks. These can be used to send out malicious packets to devices that try to connect to the evil network using that EAP protocol. Then they steal memory via Heartbleed. This is also bad for VPNs, as attackers can steal keys and certificates to gain access to private corporate gateways. So now we're going to do a little Heartbleed demonstration using Kali. First, what you want to do is you want to find the URL that you want to attack. So you'll just ping that URL in the terminal under Kali. Next step is we're going to use our trusty friend Nmap, and we want to run a port scan basically to find out if the site is vulnerable to Heartbleed. So what you want to do is you want to focus on port 443, which is the port typically exploited by Heartbleed. So you can see you have your script here. So you're going to run the script SSL Heartbleed, and you're going to put your target IP address in here. And this is a printout of what that should look like. So you can see right here it does show it's vulnerable. Okay, so now what we're going to do is open Metasploit and use the Open SSL Heartbleed module. So conveniently for us, Metasploit already has this built in. So what you're going to do is you're going to open Metasploit using the MSF console command. Then we're going to use, we want to get to the Open SSL Heartbleed module. So we're going to use, the command will be use auxiliary /scanner /SSL /open SSL _ Heartbleed. And you can see here that moves us into the Open SSL Heartbleed module. Okay. The next thing you can do is type in info, and that'll allow you to see some information about this exploit and just give you a general idea of what is going to be accomplished by this. So what we need to do is we need to adjust settings for the R host and verbose. So for our host, you can see here, this is under the info section. We don't have anything for our host, and our host is going to be our attack IP address, which is what we got from our ping. And we have our R port here. Your R port is defaulted to 443. If not, you would need to set that, and that is your target port right here. Okay, so what you're going to do, command set R host, and then you can see I blocked this out because I was able to find a website that was vulnerable and don't want to give that out. But you would do set host and then the IP address, and then after that you want to set verbose to true, and you can see a response is true. Alright, and finally we're going to run the exploit. So you'll type exploit into Metasploit and wait for everything to run. It takes, well, on the site that I did, it took maybe about a minute or so. And so now you can see it's starting to respond with a few random memory leaks. So you can see SSL record here. It did a handshake. Server says hello, hello version, server hello. Here's random data. So this is what we're getting. This is the leaked random data that's coming back. It did it again. So we have more random data, and sometimes this random data does actually contain information. Here's another screenshot of something a little bit more that was further down after the exploit was run, but you can see the heartbeat response with a leak. So printable info is leaked. So you can see here there's a lot of HTML code that was leaked here. But there's some other information that you could find through that. So you can find usernames and passwords by going through that data. So what are the lessons learned here? Basically, OpenSSL and other open source projects, they're not 100% safe. They are full of bugs, just like proprietary software. OpenSSL needs a lot more support. They need more than one full-time employee, and they need a lot more um, contributors and a lot more support monetarily. Uh, Over 500,000 sites were left exposed to Heartbleed because they use OpenSSL, um, and there's still some that are exposed, unfortunately. Testing and detection of software vulnerabilities needs to occur. Sites and companies need to practice due diligence and test software before implementing it. Can't state this enough. And the use of tools like fuzzers and human review should be conducted on software to minimize or eliminate vulnerabilities. I know human review sounds awful and a bad waste of time, but a tool or a fuzzer or a scanner, there's nothing that can replace an actual human going through and actually checking all of the structure of the website to ensure that it's not vulnerable. Other SSL TLS certificate structure needs to include revocation checking. We need to reduce incentive for hackers to find and sell vulnerabilities. I know that's going to be very hard, but it would be something that's effective here. And developers need to practice and enforce good security practices and development. So here's a list of my references, and that is the end of the presentation. Thank you.